Welcome to the shop. I'm continuing to make parts for NQALHA Production Run 4 and getting really close to finishing the 750 parts. Today I'm going to be making some steel parts that don't require anodizing and plating. These parts are going to be powder coated, so I can do them after I finished all the other parts, which are now off at the anodizer and plater. First part that I'm going to be making is, or actually not making, just drilling, is the steel base. The steel base is made from a piece of 3/8 plate steel that was cut to size by my metal supplier, so all I need to do is drill holes in it. So I'm going to drill some holes on the Bridgeport. I'm going to be using the plate, the tooling plate, off to the side. The part won't fit in the milling vise. And since the Bridgeport table only has 9 inches of travel, I can't really drill all the holes in one operation. Let me wipe off some of the chips here. So there's a number of different holes, different size drills that are used on this part, and of course I have 2 choices. I could constantly change tools, drill one size, change tool, drill the next, change tool, or I could just put in a part, drill all the holes with that size drill, and leave the drill in the machine. I kind of like leaving the drill in the machine. I think it's ever so slightly more convenient, but I probably could do it the other way too. So I'm going to load up the Heimer. The holes, it's kind of inconvenient to reach over to the manual handle there. The holes on this part are not, I mean, I could almost drill them by eye. They don't have to be made to the highest degree of machine shop tolerance, but hey, the Heimer is fast. Why not? Okay, and then turn the servo on. The nice thing about the Bridgeport CNC, the 2-axis CNC, is that when the servo is turned off, it's a manual milling machine. It's not like some of the machines where they always have the servo on and the so-called manual controls are just command controls commanding the servo system to move. When the Bridgeport servos are off, they're off. The machine is not under CNC control. So just a quick sanity check to verify that, yep, it looks like 0. So the first hole, or the first holes, the set of 4 holes are for the mounting feet, and they're going to be tapped 1032, but for 2 reasons. First of all, it's steel, and I don't want to be in danger of breaking taps. And also, the feet really don't need the strongest possible threads that you could ever make. It's perfectly okay. You know, it's only a rubber foot. The feet don't need to be tightened down to the ultimate tightness. And so, hey, I'm going to drill with the larger size tap drill for 60% thread. Okay. Peck drilling. Try to avoid the rat nest of stringy chips. And in case you're wondering, yes, it is perfectly safe to hand hold the material. It's being held in place at the back by the stop and at the side by the side stop. I'm pressing against that corner to keep the piece in place, and it's heavy, and I'm being real gentle with my feed. I haven't had a problem in all the ones that I've made. I've never had a problem with the drill grabbing, and to me it's perfectly safe. So I'm going to go ahead and drill all of the foot mounting holes, turn off the camera, and come back. So the holes for the rubber feet that are going to be tapped 1032 have now all been drilled. Next hole is a center hole, a 3/8 diameter center hole. The purpose of this hole is if you want to, clamp it down to your bench with a screw, but even more importantly, there's a Pelican case, an 18 by 18 inch cube Pelican case that fits the NQALHA perfectly for travel, and I've made a little adapter plate that kind of like a big fat aluminum washer that fits into the design at the bottom of the Pelican, and put a 3/8 screw through that with a hand knob, and you can screw the NQALHA down so it securely rides in the Pelican case. And it just, in general, it's nice to have a utility hole for whatever purpose. So, get the mill into position. Slow the speed a little bit. Don't want to go too fast when drilling steel. And once again, pushing down and toward the stop to keep the piece under control. And actually, it's throwing some chips. So, even with my peck cycle, and yes, I am being very, very, very careful. So there we have it. It's a hole. And I'm going to turn the camera off, drill all those, and then rinse and repeat. Center holes have been drilled. All is well. put the drills away and move on to the next hole, which is going to be the hole that will be threaded with a 1/4-20 thread, tapped to a 1/4-20, and this is the hole where the travel lock gets screwed into. When the NQALHA is folded into traveling position, there's a 1/4-inch threaded rod, a 2.5-inch aluminum spacer, and the rod has a hand knob on the top. And when you put the head into the right position and put in the spacer and tighten down the knob, the NQALHA is prepared for transport. It doesn't hold it absolutely secure. It can still wiggle a little bit, but it's a whole lot better than just being loose and flopping around. Go up to 3,300 here. Single hole. Pecking to avoid the long stringy chips, but even with the peck, I do get a little bit of chip action flying around, but hey, it's a hole. Oh. Gonna turn the camera off, drill all these, and let's see if you can guess what's next. Okay. One more hole. And then we will have the plates ready for tapping. And let me find the correct hole size here, 5/16. The next hole is going to be the hole in which the horizontal arm axle fits, 5/16 diameter. I'm going to be tapping these guys by hand. It's not worth doing power tapping. They don't have to be precisely perpendicular, and my eyeball is pretty good, so more holes. And slow the spindle down a little. Carefully pecking, carefully feeling for the moment of breakthrough, going through the breakthrough point very, very, very slowly. And successfully drilling holes. So I'm going to drill the rest and then turn the camera back on for the last and final step. So holes have been drilled, and get a towel here. These pieces of steel are just 3/8 by 12 steel bar, steel plate that was cut to length on the bandsaw, and these edges are like really sharp. They're like razor sharp. So I'm using what they call a strip disc. It's kind of like a really gnarly Scotch-Brite on an angle grinder to just clean it up a little bit. And do have a comment. This is mill finish steel. And no, I don't take the time to remove the mill scale and sand it to a beautiful brushed finish to try to get, an absolutely perfect, showroom perfect, Class A automotive finish. It's a base. It goes in a glassworking shop. I've seen what they look like after a few months of use. I make it, roughly smooth, get rid of the sharp edges, kind of clean it up a little bit, wipe it with acetone, and call it macaroni. Actually, that towel is not a good idea. Trying to keep it from sliding around on the table. But and that's about as good as it gets. I'll wipe them down with acetone, take them off to the powder coater, and the next piece that I'm going to be making will be the horizontal arm, which will be made on the Tormach and also sent out for powder coating. So, see you later. The bases are drilled and tapped and cleaned and prepared as well as I'm going to prepare them. Like I said before, they're not going to be a Class A showpiece finish. They're just going to be, they're going to look good enough. The next part that I'm going to be making is the horizontal arm. And it has some interesting machining challenges. It's made out of this 1.5 by 1.5 by 16th wall square steel tube, and I need to mill a press fit for a bearing on one side and a matching hole on the other side. So if I just put it in the mill like this and flipped it over, I probably wouldn't have a really good time, because that distance is not, this material is not precise to within 1,000th or 2. So I have to keep this corner as the reference throughout the entire operation. I can't cut both holes at the same time because my end mills aren't long enough, and I don't want to get a really long end mill because it'll just shatter at the end. And so I mark this. Let's see if you can see, I got a little Sharpie mark there. I mark the reference point. This is the 0 point. And for the first operation, it goes in this vise. Then for the second operation, it's flipped over and goes to that vise. This ends up being work offset 5 and work offset 3. This method produces accurate parts that work really well. I've done all of this setup off camera. If anybody's interested in seeing how I use the Heimer indicator to find 0 or load the tool changer or all the other things that I do to prepare the mill for use, well, it's all available in other videos, particularly the first 2 in the series. So I'm going to start off milling the press fit for the bearing, and it is a press fit, so I want it to be pretty darn accurate. And so I'm using 2 different milling cutters. The first cutter that I use is kind of like the cutter that I beat up. It's my rough cutter. And I realize that taking heavy cuts in steel is going to provide a certain amount of tool wear that I don't really want to have to compensate for. I just realize that it's happening. So the rough cutter is going to be taking the wear, and then I switch. I suffer the pain of a slow tool change on the Tormach, and switch to my finish cutter that I never use for roughing, and frequently inspect it and measure it to make sure that it's still in good condition. So rough cut first, then a finish cut, couple of holes, and time to run some parts. And like so many of my other tool paths, this one ran the last time I used it, so I assume it's good, but hey, you never can tell. Okay, so that was my first memory failure. Holes are first, not milling. Single block, finger on the stop button. Looks like it's pre-feed correct, feed correct. This is a clearance hole for the 1032 screw that holds the horizontal magnet plates in place. It is not tapped. 16th wall is not enough to tap, so I use a nut on the part. And those, they look like happy holes. So now comes the milling operation. 5/16 solid carbide. Probably could optimize that a little more to avoid the rapid, but I can go crazy optimizing things, spend more time optimizing than I do milling. Okay, finger on the stop button, single block mode. Everything is looking nice. I might just go and give my coolant a little bit better aim. I do like that flood coolant. Sometimes, as I've said in other videos, sometimes I get in trouble on the Bridgeport with the mist coolant when I'm too aggressively milling steel, and I end up burning up my cutter. Okay, that's looking pretty good. Plunge. 3,000 RPM, 8 inches per minute. Sounding pretty smooth. And yes, the end mill does have a grind on it that makes it suitable for plunge cutting. Okay, there we go. Everything's looking good. Time for the finish tool. Finger on the stop button. Single block mode. Stopping in the right place, pre-feed correct, into position, 3,000 RPM, 15 inches per minute. Okay. Everything is looking good. I'm gonna take this guy out of the vise. I have one of the bearings here. This is a flanged bearing, and I'm going to do just a quick sanity check where the bearing does not fall in. It feels tight, and based on previous experience, this will be a very, very nice little press fit. So, oh, one thing that's interesting about this, after the part is powder coated, the powder coat builds up on the edge of the press fit, and if I try pressing the bearing through the powder coat, I end up in all sorts of trouble. So after powder coating, I have to use the Noga deburring tool to scrape away a little powder coat to get down to the original steel surface, which is machined highly accurately and makes a really, really nice secure press fit. So I'm going to run all the parts on the first operation. There are 4 operations total on this part. I'm going to run all the first operation parts and then turn the camera back on and see you later. The first operation has been completed on all of the parts, and as I said in the earlier segment, it's very important in this to keep the reference point at this point. And of course, when I flip it over, up is now down and down is now up, and it's important that this surface be perpendicular to the sides. So I cut the blank on the chop saw, and the chop saw works really well, but it's not a super precision tool. I basically cut it with a Sharpie mark and checked it with a tape measure, so it's good enough for its intended purpose, but I can't depend on the distance here being accurate within a couple of thousandths, and I can't depend on it being perpendicular to the degree that I need. To improve the perpendicularity, I took it over to the disc sander, and I didn't show this on camera because you can just about guess what it is. It's a disc sander. I set up the disc sander with a precision fence and a machinist square so that the disc was perpendicular to the table, and then sanded both sides to make them perpendicular. Now, the length is still, it's good enough. It's probably within, 10 or 20 thousandths, but the connection between the back of the horizontal arm and the circuit board mount requires 2 holes here to be drilled pretty darn accurately. There's a hole on the other end, but it can be wherever, it doesn't matter. So that's another reason for choosing the 0 point the way it was chosen. Making sure you understand where the reference surface is, and don't assume that a part is square, the proper dimension, straight. Don't assume anything. Always measure and choose your reference surface carefully. So, going to get ready for the second operation here. Also a known trusted tool path, but like everything, known and trusted is fine. So it looks like it's going to the right place. G58, work offset 5, single block, finger on the stop button, stopping at the right place. Looks completely sane. Looks completely correct. Now for the rough mill, the 5/16 rough mill. I probably could optimize that rapid out of there, but finger on the stop button. Single step mode, single block mode. Down into position. Plunging in. 3,000 RPM, 8 inches per minute. Looking good. Switching over to the finishing cutter. 3/8 solid carbide, 4 flute. Some sort of coating. I don't know what kind of, I don't know what the coating is. It's black. Black coating. Stopping at the correct pre-feed. Stopping at the correct feed. And there we have the second operation. So I'm just gonna give it a quick inspection here. Take out the machinist square and verify. Yes, in fact, the two holes line up acceptably well. Everything is going nicely. Gonna go ahead and run the second operation and then turn the camera on for the third operation and then the fourth. So, see you later. All of the second operations have been completed successfully, and now it's time for the third operation, which is drilling one hole. And, you know, how can that go wrong? Well, there's a whole bunch of orientations that this thing could be placed in. Only one of them is right. So, just to make things easy, I've got a known good part that is known to be correct. And of course, I throw an eyeball on it and verify that, yes, the circuit board mounting screws are at the back. This screw is at the front. I kind of look at it and imagine and get fingerprints all over it and kind of imagine that, yeah, that's kind of the way it looks. So, going to be drilling a single hole. Work offset 3. 0 at the top of the part. A clearance hole for an 832. Single block mode. Finger on the stop button. Pre-feed correct. Wow. It's a hole. The whole hole, and nothing but the hole, so help me hole. Well, hey, that was exciting. So I'm gonna go put some more holes in and then back for the last step, the fourth operation. Second operation holes are all complete, And the third operation simply flips the part and puts in 2 more holes. And once they are done, the part will be done. Single block, finger on the stop button, looking good. Check it against the known good one that with the fingerprints all over it, everything looks good. So I'm going to finish running these parts and wipe them down with acetone and maybe give them a little Scotch-Brite and then send it all off to the powder coater. And this will complete the powder-coated parts. So now the anodized parts, plated parts, and very, very soon the powder-coated parts will be complete. There's a few other parts that I need to make that are nothing more than cutting stock to length. So about the only thing remaining is finishing the handle and finishing the lever and maybe a couple other things. So boy, I'm getting close to the end now. Of course, I'm going to be showing the assembly of the circuit board, wiring harness, connectors. Well, at least I'm going to try. It may turn out that getting the camera to get a good view is going to be impossible with just one guy since I don't have a camera operator. But anyway, I'll certainly give it a try. So thanks for watching. It's been fun.